Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today we are going to discuss about the transfer learning in deep learning, a neural network. The transfer learning in deep learning involves leveraging a model or knowledge gained from one task or a source task to improve the learning on a different but related task or targeted task. This approach can significantly enhance efficiency and effectiveness of training a deep learning model, especially when labeled the data for the target task is limited. The basic keynotes in the transfer learning, the motivations and the benefits of learning this is all about data efficiency. Transfer learning reduces the amount of labeled data required for training a model on a new task by leveraging the knowledge from the related task where more data is available. And the faster convergence, this model initialized with a pre-trained weight, often converging faster when fine-tuned on the targeted task, reducing the computational resources and the time. Improved performance. Transfer learning can lead to the better generalizations and higher performance in the target task, especially when the source task is sufficiently related. The type of transfer learning is where the inductive transfer, the transfer learning where the source and the targeted task are different but related. This is most common form of transfer learning. And we have a transitive transfer, directly transferring a knowledge from the source domain to the targeted domain without requiring a label into the target domain. The approaches of these transfer learning where the key extractions use a pre-trained models like CNN or the transformers as a future extractor. The learned features can also be used as an input to a new model that is trained on the targeted task. The fine-tuning the parameters of pre-trained model on a new data sets. This involves updating a weight in the deeper layer while keeping earlier layers which capture more general features relatively weighted or fixed. The domain adaptations adapts a model trained on one domain to perform well in another related but different domain. This is useful where there is a benefits in the data distribution between the source and the targeted domains. Examples of transfer learning in deep learning. Image classification transform the learning using a trained models like SNS, VGC, or effectively task for a task with object recognitions or medical image analysis. The natural language processing, where it has a fine-tuned language models like GPT or STB and specific tasks like sentimental analysis named entity recognitions or the text classifications. These were the basic classifications of the transfer learning by induced transfer learning like inductive transfer learning, transitive transformer learning, and supervised transfer learning and self-taught transfer learning process, domain adaptive transfer learning, and sequential transfer learning. So these were the different types of transfer learnings which all focused on the transfer using a pre-trained models. The future implementations or the challenges in the transfer learning is task similarity, data qualities, and overfitting. The task similarity transfer learning it work best when the source and the targeted task are related. Performance may degrade if the tasks are too dissimilar. The data quality, the quality and representatives of source data influence the effectiveness of transfer learning. Overfitting or fine-tuning too many layers or used too large learning rate can lead to overfitting on the targeted task. The future direction improving the transfer learning algorithm develop more robust transfer learning technique that kindles a diversity transfers and the data distribution effectively. We have a domain adaptation, enhance a method for adapting a model across a domain with a different data distribution, and the multitask learning where it explores the methods allowing a model for simultaneous learning from the multiple related tasks, enhancing a transferability and the future representations. We also conclude by stating the ethical considerations where they address ethical implementation such as bias in amplification when transferring a knowledge that results from the bias datasets to a new task. Hence, I hope with this understanding, I conclude by stating a transfer learning continues to evolve a cornerstone in deep learning research, enabling more effective and effectively deployment of AI system across various domains and applications. I hope you're clear with this concept. Thank you.